NVIDIA bought the company behind Slurm. It looks like just software, but it's a power move. Whoever influences Slurm influences how thousands of machines use CPU and GPU. And in AI, that becomes time, cost, and competitive advantage. To set the stage, on December 15, 2025, NVIDIA announced the acquisition of SchedMD, a company tied to Slurm's development and support. The main message was, it remains open source and vendor neutral. With that in mind, let's translate this into everyday reality. Many people think the competition is just who has the fastest GPU. But when you run a cluster, costs spike for two simple reasons: idle machines and machines being used the wrong way. This isn't theoretical, it's operational. And this is exactly where a key term comes in: scheduler. A scheduler is the cluster's calendar organizer. It decides who runs, on which nodes, with which resources, and in what order. Without that, it turns into manual fighting, waste, and unpredictable queues. With the scheduler introduced, it's worth understanding where Slurm fits in. Slurm is widely used in HPC. HPC means high-performance computing, large clusters and supercomputers used by research and industry. And increasingly, parts of large-scale AI also use this kind of environment. To complete the vocabulary, one more concept: job. A job is a task you send to the cluster to run, like training a model. Workload is the set of jobs an organization runs over time. When the workload grows, the queue becomes the bottleneck, and the scheduler becomes a critical component. So what does Slurm do, objectively? Three things: resource allocation, it reserves CPU, GPU, and memory. Queue and priority, it decides the order based on rules. Execution and control, it starts, restarts, logs, and manages jobs. That's why it carries so much weight. Now, how these resources relate. CPU is the general-purpose processor. GPU is specialized for parallel computation, which is why it's heavily used in AI. Memory, RAM, is where work stays open while it runs. If you allocate these three poorly, you pay more and deliver less. And as AI grows, another term shows up: distributed training. That's when training is split across multiple GPUs, sometimes across multiple nodes at the same time. For that to work, the scheduler must reserve resources in a coordinated way. If it can't, you lose efficiency and time.